Okay, so now let's talk about the application of separation processes. That's also will be what we're gonna learn in this course. That include distillation, absorption, and extraction. Distillation example is distillation or vapor liquid equilibrium. Let's say we have a liquid mixture A and B. A is more volatile, while B is more difficult to evaporate. Let's say acetic acid and water mixture, where A is more volatile and acetic acid is more difficult to evaporate. So how to separate A and B? We have to add separating agent. In this case, if we add energy in the term of heat, uh, some of them will be partially evaporated, while the other component that less likely to evaporate will stay in the liquid phase. Therefore, we can separate a mixture A and B. So in the vapor liquid equilibrium, after the equilibrium, if we add heat or if we add mass, or for this case is heat, it will change operating condition. The temperature and or the pressure will be changed, and after if the condition is changed, that it will have a new equilibrium. After equilibrium, the composition in the vapor phase and in the liquid phase will have different composition. For example, a much more volatile component would be in the vapor phase. For this case, is the vapor phase will be rich in A, component A, and just very few left in B. And in the bottom phase, or first case, this liquid phase, B is difficult to evaporate, so B will remain in the liquid phase with still a little bit of A. So equilibrium composition is affected by conditions, the pressure and temperature, and also the composition, of course, of those components. Another example of application of separation processes is absorption. Absorption is different with distillation, where absorption is actually gas liquid equilibrium. So in the first place, we have a gas mixture comprised of, let's say, S is and G. Let's say G is an inert gas, and S is the compound, and we want to separate S from the G. So we add a separating agent. For this case, is a liquid absorbent, which where the absorbent is much lower to S, so it's chosen preferred by S. So if we add the S into the gas mixture, and we have a very good mixture, S will diffuse into the adsorbent liquid until it reaches equilibrium. And then what we have in the end is the amount of S in the gas will decrease, while some of the S compound would be absorbed in the liquid separating agent. Again, the composition is affected by temperature and pressure. Yeah, so absorption is the liquid solute from the gas carrier gas involves transfer of the solute through the gas to the gas liquid interface, across interface, and into the liquid. Another example, this is going to be our last module, is extraction. Extraction is a liquid-liquid equilibrium. So we have a liquid 1 contain S, let's say, and we have liquid 2 also. So the separating agent is actually the liquid to a liquid absorbent. It is selected by preferred by us. So the difference between absorption is the system started with a gas liquid system, but for in extraction it's contained liquid system. The equilibrium composition again is affected by condition. So usually in extraction, we have two phase, and in the end there would be an extract. An extract is the liquid that have contained more as compound that we want in the end, and the remaining solution is called raffinate. Raffinate is the remaining solution that still have a little bit of S compound. So extraction is a species from a liquid mixture. Involve transfer of the solute through the liquid to the liquid-liquid interface, across interface, and into the solvent. Based on the previous explanation, so equilibrium is really natural things. This is that the God give it to us. So equilibrium is a function of temperature, pressure, and we need to understand equilibrium composition in various conditions. And equilibrium data is actually thermodynamic data, and over the years since 1940s, 1950s, so scientists have gathered a lot of equilibrium data, so we have very vast thermodynamic data available for common system. However, for other system that is quite new, we need to make an experiment to obtain the equilibrium data. So if we have other system that hasn't been where the thermodynamic data has been available, so we have to obtain from the experiments, and it is difficult to do, and also it's expensive to predict.